Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, today we are looking at this question. It says that magnesium and chlorine react to form ionic magnesium chloride. Okay. And then the question says that explain the difference in electronegativity between the two elements. Yes, what is this difference? Okay, you need to know that here they have mentioned that the compound formed, which is magnesium chloride, is ionic in nature. And ionic compound is formed between very electropositive atoms and very electronegative atoms. That is implying that the difference between electronegativity must be big. Yeah, then we come to this question. It says that magnesium and chlorine react to form ionic magnesium chloride. And they say write the chemical formula of each of the following. The first one is magnesium ion. Yes, what's the chemical formula of magnesium ion? Okay, we need to know that magnesium belongs to group 2 and it has valence 2. So in other words, to attain stability, what magnesium does is to lose the 2 electrons. After loss of 2 electrons, it attains a positive charge with a +2. Yeah, then we come to chloride ions. Yeah, we need to know that chlorine belongs to group 17, having 7 valence electrons. So to attain stability, the best alternative is to gain 1 more electron and its outermost shell or outermost energy level attain octet state with 8 electrons. So because it gains 1 electron to attain stability, it attains a negative charge. And that negative charge, we indicate it like Cl with a minus here. Okay, then lastly, ionic compound formed during the reaction. Okay, the ionic compound formed here is magnesium chloride. And magnesium chloride is made up of magnesium ions and chloride ions. We need to know this, that the actual formula is magnesium having valence 2 and chloride having valence 1. In exchange the valence, we have magnesium chloride with a 2 here. Now, if you are indicating this one ionically, you can write magnesium with a +2 and the 2 Cl minus. Yes, this is it. Yeah, then we come to this one. It says that write balanced equation for the reaction taking place. Okay, so what are we having here? We're having magnesium. Normally it's a solid, and reacting with chlorine, which is a gas. And what you get out of this one is going to be the product, which is magnesium chloride. Yeah, we have to know that magnesium has valence 2 and chlorine has valence -1. In exchanging the valence, this is what we get. But the question says that the equation must be balanced. So let us look at here. Magnesium is 1 here and it is 1 here. So magnesium is balanced. And chlorine is 2 here and 2 there. So it's balanced. This one is a solid in nature. Yeah, then we come to this one. It says that draw Lewis dot diagram for magnesium chloride. Okay. So you need to know that magnesium chloride is made up of two elements. It's made up of magnesium and chlorine. So if you look at magnesium first, this is what you have to know, that magnesium belongs to group 2. Group 2 has 2 valence electrons, indicated like that. So to attain stability, the best option is for it to lose the 2 electrons. So we can indicate it here that loss of 2 electrons. So loss of 2 electrons take away the 2 outermost electrons we had. So we have magnesium now, Mg. But we must remember that when you lose electrons, you attain positive. So this one becomes 2 plus because of the loss of the 2 electrons. Okay, the other element we have to look at is chlorine. So chlorine belongs to group 17, and group 17 has 7 valence electrons around it. That's how we indicate the 7. So the best option for this one is to gain 1 extra electron to attain stability. So in other words, we can indicate here gaining an electron. So when an electron is gained, this is what we are going to have. We are going to have our symbol there, and we indicate all the electrons we have in the outermost shell. We must not forget that 1 more electron has been gained, so you can indicate it here. Now, because this atom has gained an electron, it attains a negative charge. And we indicate the negative charge like this. We put a bracket and we put the negative charge there. So now we come to combining these two. Okay, if you look at our formula here, what do we see? We are seeing that we have 1 magnesium ion and 2 chloride ion. So that's what we're supposed to arrange. So if we indicate our magnesium like this, we can put a bracket or not. For magnesium is not a must. Then what else? We can bring our chloride ions. You can put 1 this side, which is Cl, and indicate all the electrons, which is 1, 2, 3, 4, 5, 6, 7. And we remember it gained 1 more, so you can put it there. Then conventionally, we are supposed to put a bracket on this, and we put a negative there. Okay, that's 1 chloride. Remember, there's supposed to be 2. The second one, the best option is to put it this side, and we say Cl, that's the symbol, and we indicate all the surrounding electrons. Those are the 7. But remember, to become negative, it gained 1 extra, so we can put it there. And it's conventionally a must that we put the bracket around here, and then we indicate the negative charge here. So what you have here now is the Lewis dot diagram of magnesium chloride. And with that, I'd like to thank you for your time. The channel is PSSB, Physical Sciences Silver Plate, with me, Richard, here. We appreciate your time. We urge you to subscribe. We believe that we are simply the best. Stick with us. See you next time. Bye-bye.